to our presentation, On to New Shores, USD and Solaris in a feature film pipeline. My name is Andreas Giesen and I work as a VFX supervisor at RISE. I started in 2011 as a VFX artist, later soup. So I've been working with Houdini and at RISE for more than 10 years.
Hi, my name is Ohler. I've been at RISE for almost 15 years now, working in multiple positions. My main focus now is pipeline development, where I recently worked on integrating USD and Solaris.
Cool, Before we get started with USD, just a brief overview about RISE, starting with a short version of our last year's reel. We would like to start by giving a very quick overview of how we have been using Houdini for lighting, look diff and scene assembly over the years, and how we naturally ended up with switching to USD and Solaris for most recent iteration of our Houdini pipeline.
We started using Houdini in 2011, where we did only a handful of shots for a project called Cloud Atlas. But we really like the workflow and overall experience. So for the next project, The Man from U.N.C.L.E., we implemented the first iteration of our lighting and rendering pipeline, and that was very much based on the object level. So every asset came with its own HDA, and every additional instance of that asset would also create an additional node instance. So when we imported sets or animations, we ended up with a lot of nodes in the object level. So while this approach was very accessible to new artists, it was not really ideal performance-wise, and it lacked a lot of the procedural flexibility that Houdini has to offer, like in SOPs, for example. So naturally, the next step was to move everything into SOPs. Instead of creating object-level nodes for each asset, we created new loader nodes for different contents of a scene, like sets, animation, or effects. And a single node could now bring in hundreds of assets at once, which of course meant a huge boost in performance, and now also allowed artists to use wrangles and all sorts of procedural logic to divide up their scenes. But probably the most impactful addition to our pipeline was when we added a way to do sequence lighting in Houdini. And by sequence lighting, I mean being able to manage and render dozens, if not hundreds of shots from a single HIP file. And we added this functionality already in 2017 with a toolset called Shot Machine. And Shot Machine at RISE is used pretty much like its own Houdini context, like out or cops, though in reality it is just a subnet. But instead of loading geometry, it would load shots or whole sequences of shots, and each shot would just be represented by a single point. And by having the shots available in a Houdini network, artists could then select what elements should render. They could set up different priorities, and most importantly, they could override any parameter or setting in their scene. So per specific shot. So in general, it was already a very, very flexible setup, and it is still used on the non-USD projects that we're currently working on. And I'm telling you all this because with the loader nodes and shot machine overrides available, it might seem that we already had a lot of things working that are also achievable now with USD and the context switches in Solaris. So when Solaris was initially announced, we also had to ask ourselves what are the benefits of putting in all that work and basically rewriting such a major part of our CG pipeline. So here's some of the reasons why we made the switch. Reason number one was not initially USD, but to finally have this unified context for look dev, scene assembly, layout, lighting, and rendering, which basically describes Solaris as a product, and really was something we have been looking for and wishing for a long time. And as you've seen in our legacy pipeline, everything was different, split up in so many different contexts, even with a shot machine and added as well. So when Solaris was finally announced, of course, we wanted to be able to use it as soon as possible. Then the concept of having a shot and an asset USD. It might sound strange now, but in our legacy pipeline, we never had this explicit definition of asset packages or specific versions of a shot. Shots and assets were always in flux, and individual elements would update, but there was never this one file that would represent a shot or an asset at a specific point in time. So yeah, packaging our assets and shots was long overdue. And then, of course, all the USD features, layering contents of different departments, where you could do sparse overrides. An animation layer could just be a transform on the layout layer coming before it, and payloads, of course, deferred loading of geometry, layer muting, and variants, of course. We use variants a lot in our props and also in our crowd workflow. Full dependency tracking. So for a long time, we wanted to be able to take a final comp and browse through all the elements that were used, be it animation or textures. So while this is not USD-specific features, when having to rewrite such a big part of our pipeline, it was so much easier to implement this. And then, of course, Karma and MaterialX. Karma is now a really great production-ready renderer. It's fast and it's reliable. And MaterialX is really important because we wanted to have a future-proof way of working with materials in USD. We're currently rendering only with Karma CPU, but in the future it might be XPU or even other delegates. So MaterialX was definitely one of the features we needed to see implemented before being able to make the switch to a USD pipeline. So how did we go about implementing it? We started R&D in mid-2019 with the Houdini 18 Alpha. And the idea was when Karma and Solaris are ready, we wanted to be ready as well. So yeah. But there were a lot of things we had to figure out before we were starting to write code or start building HDAs. And yeah, we had to come up with a structure. How would we compose and structure our assets and our shot and layer files? I mean, there's a general concept out there, but everyone is doing it slightly different, and yeah, I guess so do we. Then, that was a major thing. We had to switch from a pull to a push pipeline. In our legacy pull pipeline, when artists opened a work file, they were asked if they want to update certain elements in their scenes, while with USD, or at least the way we implemented it, elements would automatically update in artist scenes. But this new auto-update behavior also required us to have a solution for cases where we don't want this automatic update. Like when something is rendering on the farm. We don't want to have the assets switch versions mid-render. So we needed to look into building our own asset resolver. And then with all this figured out, we started working, and until now have built more than 60 HDAs, or it might be even more now. And the idea there is that by wrapping the core nodes of Solaris into our higher level HDAs, this just allows us to hide a lot of the complexity of USD, which can be complicated at times. And it also allows us to control their usage in the network. But it was not just building HDAs, we also had to update the Maya the Houdini pipeline, the Maya pipeline, the connection to Rise-base, which is our in-house database, and SpeedTree, for example. So it was many parts in different areas. But then, in the end of 2021, we were ready to tackle our first USD project, and more about this now from Andreas.
Yeah, so I mean, to be honest with you, it was not an easy decision to make if the last voyage of the Demeter here should be our first USD project or not. Because as Simon already mentioned, the pipeline team was working for quite some time on USD at Rise to overcome the several challenges, but at some point we had to make this decision. So let's see the facts we were facing in August last year. The last voyage of Demeter just finished shooting in Malta, and the scope for the show was quite big, actually. The movie is set at the end of the 19th century and is based loosely on Bram Stoker's Dracula novel. More specifically, it's about the voyage of the ship Demeter, which has a terrifying cargo loaded and travels from Varna in Bulgaria to London. But then what arrives near Whitby Harbour in England is not much more than a ghost ship. So, based on the script, on the one hand, we had to prepare for extensive environment work to bring the city of Varna and especially the harbour to life. And on the other hand, also for full CG shots with complex FX work, as the Demeter must endure more than one big storm during this voyage. So, shot count was supposed to be about 300 shots. And as just mentioned, with a bigger number of full CG shots than any other show before at Rise. So, yeah, I mean, was this really the perfect project to get started with USD and MaterialX and Karma? Yes and no, I would say. So, the scope of the whole show was almost intimidating, the huge shot count and also complexity-wise. But, yeah, we also knew that only a project of that scope would really put the new USD pipeline to the test to establish it as the new pipeline at Rise for all future projects. Also, the time frame of the project was long enough. All core features of the old pipeline were available in USD, plus the new flexibility. The results of performance testing looked very promising. The team on the show at Rise had worked more than once in the past on the edge with new developments, and we knew also that side effects would provide their great support as always. So we made the decision, last voyage of Demeter would be our first fully USD-based project, and everybody hoped that this journey would have a different outcome than the one from the crew of the Demeter. So, a little spoiler ahead. Say it did. At least all artists survived. But yeah, I mean, there were several challenges along the way. So let's have a closer look at this harbor environment here to break down our new USD pipeline step by step. Starting with a single asset to get to the final shot after modeling, texturing, shading, assembly, layout animation, FX, lighting, and rendering. So let's get started.
Okay, yeah, let's start with asset build. Asset most of the time starts with a model layer, and in our legacy pipeline models we'll always need to go through a Maya export. But with USD this has now finally changed. This is Houdini, of course, and here we can see two variants of a model being loaded from SOPs, and to simplify the setup we added custom model pack and model out nodes. And by connecting a reduced version of the model to the pink inputs, artists can quickly define them as a proxy purpose. Then they can name their variants and bring them into LOPs via an import model node. And once we have the geo in LOPs, we can see the variants have been created. And to then define the import as its own layer for export, we create a Rise export asset node where we can then set the name and the type of the layer. And in this case, yeah, it fetches it from the scene name, and yeah, the layer is model. We could now export this right away as an asset with only a model layer, but we can also define an additional Houdini surface, additional surface layer directly in the same file. Here we've already set up some materials which live in our material container node, and as mentioned, we try to use MaterialX for almost all our materials. The material container node also allows us to easily reference materials from other assets. In this case, we reference them from a material library asset that now added an additional gold and plastic prim. So they are now, the green ones there, are referenced from the other asset. And for doing material assignment, we have created some custom nodes and created this template network that we see here, which makes it easier to do set up nested variants. And to do this, we first select the variants into which we want to add our assignments. In this case, we have a LOD and a model layer. And then our material assignments happens. In this example, we're replacing the metal with the gold material that we just referenced from our asset library, or material library. And one great thing about USD and MaterialX is that we're still able to edit that reference material. So by creating an edit property node via the scene graph tree, we can still adjust the color of the material coming from somewhere else. And then in this network here, we've just connected an additional export asset node on which we now define this upstream assets as the surface layer for this asset. With our additional layer defined, we can now open our publisher UI, and it will look for all export asset layer nodes. And if these are chained together, like in our case, it will combine the output into a single asset package that then payloads the layers generated by each export node. And both of them will be exported, and the resulting file will be this new asset package. And we then run our validators, make sure everything's fine, and then we publish. Now, with our asset being exported, let's see what I mean by this asset package in more detail by inspecting the resulting file. We can bring in our just exported asset using a RISE reference node, and we can already see that it comes with geometry and applied materials, and also the variant sets are there. And if we now look at the layer structure, we can see that we are referencing in an unversioned latin.usd file, which payloads a model and a surface layer, and that the surface layer also has that reference to that material library asset. And one thing to note about this Latin USD is that it is not really a file itself, but it is only a symlink to the latest versioned Latin USD file, like Latin version 5, for example. But simply by looking at the scene graph layers here, we can't really tell what that actual version of that file would be. So this is where asset info metadata comes into play. When we check the assets root prim, we can see that the export nodes generated a lot of additional metadata for this asset. And this is because, like I mentioned initially, dependency tracking was a big requirement for our new pipeline. So if we now look at the identifier entry, we can see that the real version of that asset is actually version 5, even though it is listed as that unversioned symlink in the scene graph tree. But there's also an even simpler way to get to that information for this asset or any other asset in any scene, and that is through our pinning UI. And if we quickly open it, we can basically see the same information as under asset info, but presented in a nicer way. It is version 5, and it is the latest. But what we can also do here is now switch the asset to any previous exported version. If we hit apply, we can see the asset change in the viewport back to a previous export. So while generally we try to stick to the latest pushed version of an asset, this functionality is quite important to have, as there will always be cases where we need to change a version only for a specific short or HIP file, and be it only for debugging purposes. And being able to pin assets this way is possible because we implemented a custom asset resolver, and ours was initially based on the replace resolver that was open sourced by RodeoFX. And what the asset resolver allows us to do is remap that unversioned Latin USD file that by default always symlinks the latest pushed version, as we can see on the left, to any other version of the asset. So on the right side, we can see that when an asset gets pinned, the symlink is ignored, and the asset resolver now maps it to a different path.
Yeah, so I mean, once the first assets were in place, we also had to start with assembly of the different sets. I mean, so far we used Maya for assembly at RISE, but USD provided the flexibility to move this process to Houdini as well. That's why we decided to have a closer look at this option, and Jenny Leupold, our CG soup, and her team evaluated USD assembly in Maya and Houdini. Actually, they started to build the Warner Harbor set in both applications. But quite soon it became clear that Solaris offered more features, flexibility and stability. So another innovation at RISE, a set built in Houdini. But what exactly are these advantages? Let's get back to a single crate here. As Simon already explained, assets can have different model and material variants. To create a pile of crates or baskets, it would be possible to use model variants, but even more flexible is the multi-prop. Using this asset type, the layout artists can create, from within their assembly scene, new packages of assets exactly as they need it. Important to mention here, those won't be model duplicates. All crates are still instanceable references, which makes it very memory efficient. Also, this multi-prop asset can contain variants, like here, different arrangements of crates. Once it's pushed, they can directly reference it, like a normal asset, and switch easily the different variants without opening another scene. Of course, all these multi-props are normal assets in the database, so they can be loaded and used in any other scene as well. Combining several of those multi-props and using the powerful layout and edit nodes in Solaris, it was quite fast to get from a single crate here to this fully dressed harbor dock we just have seen. A similar workflow was used for the harbor buildings, the ships, and the city in the far background. Thanks to the automatically generated proxies for every asset when it gets pushed, even with all payloads visible here, the scene is still workable and interactive. If needed, shot layers can be loaded to check if the set works, also for a specific camera angle at any time of the process. Another advantage is how visually and clear it is to work in a node graph, at least in my opinion, basically a network box for every part of the harbor. In addition to that, the scene graph tree provides several options to just focus on a specific part of the scene as well. Splitting the harbor in different assembly scenes wouldn't have been an issue at all, so that more than one artist can work on it in parallel. As just a reference node, as you can see here, is needed to load and check the latest pushed version of every asset or assembly of the whole project. Looking at this shot, robust scattering for vegetation and assets in general was needed. In our legacy pipeline, we had a feature-rich and easy-to-use scatter HDA in SOP level. That now all has been transferred to Solaris and offers even more flexibility. Those highly detailed plans were created in SpeedTree, including a wind animation. The automatic export, the automatic conversion on export is basically taking care of all these assets that they are ready to use for the instancer in Solaris. As a starting point, there are several templates available for the artist, depending on if it's a normal object scatter used for FX or to instance lights. Inside is a SOP network so that the usual scatter tools can be used and attributes can be modified using wrangles like P-scale or orientation. Often the initial distribution is defined using the paint tools. The instancer prototype node here offers automatically all USD assets that are connected to the instancer so that those can be scattered right away. Using this node, it's also possible to switch model and material variants for each instance, as you can see. The same applies for color variations, animations, and time offsets, so that not all plans move with the exact same timing. Yeah, I mean, upcoming features for the assembly will be a full integration of the Solaris layout node to place the assets even more flexible and convenient. And now that the assembly is complete, next step is layout.
Yes. In our legacy pipeline, layout happened in Maya, but as with assembling sets, this has now also moved over to Houdini. We always start with a load shot node, which brings in the current state of the shot. And as we can see here, the shot already contains a lot of layers, but most of them have been muted. And this is due to our internally defined USD shot layer order. As we want to add a layout layer here, it mutes all layers with a higher order, including the current layer, which would be the layout layer, if it already exists. This is happening so that when working on a layout, layers exported from other departments don't interfere with our edits. The only layers kept active are the match move camera and our project USD template. And that template layer exists as a base layer in every shot, and it makes sure we always start with the same base hierarchy in the stage as you can see on the left in the scene graph tree. Now we can start adding elements to our layout layer. As you can see, it's quite straightforward. We just reference in our main harbor set and then insert it into our shot using our insert node, which allows us to choose one of the default shot primitives. In this case, we choose the set prim. If required, we can add shot-specific edits, like here, for a specific shot, where positions of several assets get transformed and also additional props get added. And as we can see with this additional barrels that are referenced in, and again using the insert node, are now added to the props default primitive. And by using a shot switch node, we make sure that the edit is only applied for that chosen shot. So if we then switch to a different shot, we can see that the shot switch node is disabled and the additional props that were there are disappearing again, because we're now looking at a different shot and our override is not active anymore. This switching between shots is possible because the Houdini file was located on a so-called principal shot. A principal shot is never rendered itself, but is used to control other shots that are linked to it. So if in our database we connect any shot to this principal shot, that new shot will appear in this selection menu. And in Houdini, we can read that database connection and create a RiseFX shot context option for which we define shot names as values. So the shot menu in the menu bar is just a more convenient way to access these context options in a faster way. And by working in principal shots, a single artist can control and export layers for multiple shots at once instead of having to create Houdini files in every single shot. So while we had sequence lighting in our legacy pipeline with the new principal shots, this is not limited to lighting anymore. But we can use it for all departments, as for layout here and for FX, for example, as we will see later. Now, let's quickly have a look at the publish process. To export a shot layer, we also need an export node, and in this case, it's an export shot layers node, where we can select the layer type and name, so very similar to assets. And then we again open our publisher, but as we're working in a principal scene now, it will now find all connected shots. And then we can decide which layers for which shots we want to export. We could export all of them and send this to the farm. Then we run our validators again, and then we're ready to publish the layout layer. And so now that the layer was published, we can review our export, same with we did with assets. So if we bring in the load shot node without any connected export nodes, the shot is loaded without any layer muting. As we can see, the set has been added to the shot, but there are also a lot of other elements coming from many other layers. And with complex USD shots, it can be tricky to figure out what edit is coming from what layer. And to make this easier, we added a shot info prim for each layer. So similar to assets, we have this single location where we can store our asset info metadata. And for convenience, we also added a relationship to all primitives that have been added for this layer. So if we select the shot info prim, we have this list of prims that are modified by this layout layer. Animation export. Animation export, because most of our animation is still done in Maya. And as you can see here, we use the same publisher UI as in Houdini. But in Maya, we have a special extractor that also runs an additional Python process. And you can see the tiny Houdini icon there. So the initial files we export from Maya are just simple caches that only contain point position and normals. And then the Python process generates a Houdini HIP file from a template scene that uses the same nodes that we use for all our Houdini exports. So the payloads, the variant setups, the lofting, the addition of metadata is all happening in Houdini with the same nodes we use when working in Houdini. So here's a look at one of those pipeline-only extract scenes. In this case, it is an animation export for one of our crowd characters, where additional animations are automatically created as variants. The input Maya caches are then layered over the fully shaded assets to apply UVs and rest position and material assignments. And the export node then handles the creation of the animation layer and updating of the main asset package. But again, the user does not interact with this file here. This is what is automatically generated when we trigger an export in Maya. And just to give you an overview, this workflow of generating USD files through a Houdini Python process is something we use a lot, and it's not just limited to Maya exports. For example, on the right, we can see the speed tree extraction template that is used by our speed tree ingester. And the ingester allows us to just pick a bunch of speed tree files, which are then automatically exported and with their resulting caches then piped through a Houdini extract scene to create the different model, animation, and material variants. And on the left, you can see the templates that they are created as HDAs, and every model, LiDAR, rig, assembly, and animation export from Maya goes through such a Houdini template to generate the final feature-rich USD files. So for us, the big advantage of this workflow is that instead of having to write plugins for every application or rely on existing plugins that might still be missing features that we need, we now just add a new template in Houdini and then run the export through one of these extract scenes.
Yeah, next up are crowds. As you have probably noticed, the harbor extension not only contains buildings and vegetation. We also had to fill the background with hundreds of extras. So looking at crowds in USD was another challenge. Based on the experience of previous project and some time constraints, we decided to go first with the, as we call it, cache placer crowd. That means it's not based on a real crowd simulation in this case. Instead, it's way more simple, but not less effective. Here, those agents are all pre-cached, including the Vellum cloth simulation for about 1,000 frames, and then placed in the scene using the scatter tool in Solaris I showed earlier. The big advantage compared to a full crowd system is that it's way more art directable and also very efficient, as it's not necessary to run a cloth simulation per shot here, or to worry about clip landing and so on. To prepare the crowd for all shots, we are using again a principal shot. That means one base crowd is set up for the whole dock and then pushed to all shots with one click. In the scatter tool, the agent variants can be easily randomized to change their costumes or animations. So with about 6 agents and 2 variants each, the result is a diverse crowd which worked totally fine for all those shots. The next step is to send QC renders straight from the scene, even with the correct shot lighting, if that has already been set up. After checking those renders, the crowd can be modified by removing or adding more agents for a specific shot using the shot switch. By switching the shot context, the artists are not only getting the correct camera, they will also see all layout modifications that might have been pushed for this shot to adjust the crowd accordingly. Color variations can be set up later in layout or lighting using the color variation node. So all crowd shaders are prepared so that the brightness and hue values can be modified per agent. I mean, don't get me wrong, a next step is definitely to get our full crowd simulation system up and running in USD. But depending on the use case, it has turned out that this cache placer crowd is used way more often, especially if it's not like a large-scale battle scene with thousands of agents. So how does lighting work in the new USD pipeline? As usually a sequence includes more than one shot, we are using here principal shots as well. In this case, principal lighting scenes. For example, the harbor scene has more than 50 shots and the lighting is quite similar in most of these. So first, a base lighting was set up as a starting point. As always, the load shot node brings in everything which is pushed for a shot: camera, animation, layout, and FX. No need to load different elements by hand. Of course, all benefits of Solaris can be used, like displaying bounding boxes only or loading the scene without any payloads to keep even heavy scenes workable. Options like changing the visibility just in the viewport or the solo mode here helps to enhance the scene performance even more. Using the context options, the lighting artist can switch through all the shots which are connected in RiseBase to the principal lighting scene. This makes it quite fast to set up and check the lighting for the different shots. The proper OCRO configuration also gets switched to see the shot with the correct LUT in the viewer. To adjust the lights in detail, it's best to switch to Karma to interactively tweak it. Depending on the scene size, it's even possible to switch to Karma XPU, which provides a close to real-time workflow for the lighting artist. But as some scenes of the sequence were shot at different times of day, it was still necessary to load HDRIs captures on set per shot and to adjust the sun angle accordingly. This can be easily done by using shot switches to either modify the base lighting or to add new lights per shot as well. Solaris allows to organize here all this very clearly, as you can see in the network view. Last-minute layout tweaks are also possible. even though it's recommended to do this in the layout step. Once the lighting is ready for one or several shots, it can be published and pushed. From this point on, the load shot switch node will load all published changes without recalculating it all the time. Next time we'll explain how the rendering works, which can be set up in the same file as it's here, or also in a separate rendering scene.
Okay, let's look at the rendering workflow. As for all other areas, we try to keep the render-specific nodes as simple as possible. And so to submit a render job to the farm, we basically only need two nodes, a render output node and a submit render node. While on the submit render node, we can specify the shots that should be rendered. The render output node defines the output image sequence and allows us to choose what elements of the stage we want to render. It also takes care of defining the phantom, matte, and light selections, so it's very similar to how it worked on the mantra nodes in the out context. In addition to defining the render selection, the render output node also creates the default render settings and the render products. We create a beauty, preview, and util product by default, and if required, a deep product can be added as well. The node handles the creation of all the default render variables, including per light exports, cryptomats, as we can see here, and additional util channels. But all this without any user interaction required. But if artists do need to create custom AOVs, we've added a simple function to connect them. So the two inputs on this collect additional render vars node represent the util and beauty product. And by connecting the new variable to the yellow input, that additional render var is then now available on the util product. And yeah. But from AOVs back to rendering again, in a production scene, we rarely just render a single image sequence. But scenes are often get split up into many different render elements. And to set this up, the first thing to do is put the stage's contents into individual collections. And then we create a Karma render properties node. So we have this initial location to define our render settings, which can of course be further refined downstream. We continue to set up our different render output nodes with different selection of elements from the scene that should be rendered. And then we group them into collections by using a collect render output node. This will allow us later to assign a collection of render outputs to a specific shot. One thing to note here is that this collect render output node is not actually merging the inputs, but it is acting as a switch node that is again controlled by a context option variable. And the node that lets us control this context option is our preview render node. It allows us to switch between all available render outputs without having to jump around in the network and change display flags. Also, phantom, matte, and light selections are all ignored upstream to still keep them editable till the end and are only finally applied by this preview render node and of course the submit render node. In addition to switching render outputs, we can also use the node to directly switch to another shot as we did here. Now to further refine the initial render settings. Here we want to activate depth of field only for one specific shot. We activate it using an edit properties node and make sure it is behind a shot switch. But in this case, the amount of blur will require higher sampling. And as we already set up a separate render output for this front area named table, we can add an additional override only for this render output, where we increase the pixel samples to 20. We can see them being applied in the scene graph details, and if we now switch back to another output, we're back at the initial value of 9. So it's only applied for that render output. And I think even with this simple example, it just shows how incredibly powerful working in Solaris is and also tweaking these render settings by having the option to still control and override every single property up until the final node in the network. And in our case, this final node is often the submit render node. We use it to select the shots we want to submit to the render farm. But what we also need to define are the render outputs that should be rendered per shot. Otherwise, all connected render outputs would be submitted for every selected shot. And we can now control this using this select render output node. This node allows us to pick one or multiple shots and then the required render outputs for rendering. But instead of having to pick them one by one, we can now access this collection we created earlier using the collect render output node. This is, in this case, output close-up collection. And if you now check the FNSE settings prim, this is a custom primitive type we created to connect our render farm manager. we can see that the render outputs have been added as a property and could now be submitted to the render farm. One last thing regarding the rendering workflow is that with MaterialX, we now also added texture LODs, so different resolutions of the available textures. Because in our experience, slow render times often are not always caused by the amount of geometry or amount of shaders, but rather due to slow texture streaming from the network. And as we can see here, this scene is quite big. It's almost 1.5 million USD primitives. There is crowd and there's lots of geometry, but still we're able to interact with it in reasonable speeds. And the reason for that is because we are using the lowest texture quality, which is level 5 in our case. And to be able to apply this override, we stored all our LOD texture paths as an additional property on the image shader primitive. And the texture LOD node lets us pick an LOD level and then applies it to the asset by first creating a class prim per prototype, which is then applied as an inherit to every selected asset. And we use inherits because this way we can avoid having to de-instance the asset, and it's much simpler than if you would need to create additional variants for each asset. And while here we just override it with a single value, the node also supports setting it up with different areas based on the selected camera. And so in general, when we're setting up our general lighting, we almost always set the texture LOD to a really low quality, as it allows for these interactive speeds. But also in final renders, we rarely use the highest quality, as for camera positions like the one we see here, there's absolutely no need to try loading the 4K UDIM patches.
Yeah, I mean, similar to the principal lighting, we also introduced the principal FX scenes. A good example is the ocean spectrum principal scene. Here we set up all ocean spectrums, basically the look of every single ocean surface for the whole show. This was a huge time saver, as it was pretty much always the same setup, just with different spectrum files that had to be created and also tested before pushing those into the shots and making them available for further FX simulations and lighting. As you can see here, in the end, we ended up with more about 40 different oceans. Getting all the shot layers like camera, animation, and lighting using the load shot node helped tremendously to preview render those quickly within the real shot environment. We also made the experience that oceans react very sensitive to lighting. Just a few degrees change in the environment light rotation could make the difference if it looked realistic or not. So in some cases, it was necessary to pass on a separate environment light containing a specific HDRI file. And as not only FX elements can be added to the shot using an insert node, it's easy to pass on additional lights to the next department as well. Shot switches are used to ensure that spectrums and lights gets inserted into the correct shot, or even several shots of a sequence using a flexible syntax. With a custom render setup, it was possible to iterate quickly for testing purposes. Overall, the displacement quality in Karma is quite fast and also robust, especially when adjusting the Dyson quality to a reasonable value. Also, at the beginning of the year, we had some troubles with holes in the displayed surfaces, but the side effects developers fixed that quite fast for us and even backported it to Houdini 19. Thank you. Another use case for the principal FX were also two sequences with several shots looking from the deck of the boat towards a stormy ocean in the background. Here we created one ocean and whitewater simulation for the whole sequence that could be pushed to all shots from within this principal FX scene. So no need to do custom sims for every shot or to open different scene files. Even if we noticed that one shot needed, for example, a bit more whitewater in a specific area, a shot switch could be used to add this without changing all the other shots which were approved already maybe. Once it's pushed, it can be rendered without any work done in the lighting scene, as the new whitewater is just pushed for this shot and then replacing automatically the old one. As the project had several full CG shots as mentioned, our client asked at some point if we could do an interactive session with the director to explore ideas and camera angles. Normally, we would have done this in Maya as well. But with the ability in Solaris to switch quickly between the different shots with all its contents, like the camera and boat animation, we looked into an option of doing this in Houdini. And it turned out that it worked quite well. Being able to switch quickly between Houdini GL and Karma, the preview quality was far beyond the common play blast, because to judge if a shot layout can work out, seeing it with correct light and shadow is crucial. Of course, stability in a live session like this is really indispensable. So that's why when doing the first session, I think I opened 3 times the same Houdini instance in case it would crash. But it didn't, and in the end we did, I think more than 6 of those sessions, each at least 1 hour long without a single crash. As we used a principal shot for those sessions as well, we could push the cameras created there so that they would be available in Maya for further tweaking. Speaking of stability and render performance, let's have a closer look at these stormy ocean scenes here. We knew from the beginning that shots like these would be in the scope of this show and would also need to be rendered using Solaris and Karma. In 2020, we introduced RenderMan as an alternative to Mantra for our pre-USD pipeline, and especially to make it work with heavy FX caches required quite some R&D time, and features like correct motion blur for particles was just achievable with workarounds. So it was a real relief for us as first tests showed that Karma will be able to deal with massive amounts of data and could render the ocean surface with displacement based on the spectrum in the shader, so no need to bake any maps. If we break down a shot like this, we can see that it contains several FX layers, each of those with about 1 GB or more cache data per frame, like the meshed flip simulation, whitewater, mist, rain, atmospherics, and the sail simulation. To make it work with Solaris, the render cache is not a BGO cache anymore. Instead, it's all USD. The FX work before is done as usual on SOP level with the BGO as intermediate caches. Normally the FXTD starts by bringing in some elements from LOPS with our custom import node. That will ensure that important attributes gets preserved, like the path, to be able to insert it later at the correct place. In this case, it's a ship, including the sails, to run a Vellum simulation. When the sim is done, he can drop down an export template to quickly bring back the simulated sails to Solaris, making sure all attributes for USD are still available. We have tons of these templates, as you can see, that help artists to set up everything pipeline conform, for example, a transform pieces workflow with USD. For quick tweaking, it's also possible to enable a live update without the need to cache it first. The Rise insert node makes sure to either put it back in the hierarchy, replacing the static sails, or to insert into a new FX primitive if it's a completely new element like whitewater or rain, for example. The node looks simple, as our pipeline TD Luca Scheller really did a great job here to make it easy to use for the artist, while still doing a lot of heavy lifting internally, handling all the complex USD layering and composition edits. In the end, the FX layer gets pushed and will be immediately available in the lighting scene as well. If the lighting artist had the static sails already put in a collection for rendering, he doesn't have to change anything, as the FX layer replaces the asset layer that contains the static sails. Also, materials will be passed along if new ones were created. As we are using Karma, also Vex shaders are supported, for example, for the ocean surface or pyro shaders. As always, for QC, a test render can be set up in LOPS directly from within the scene using the proper shot lighting. In the last months, we could also implement that the Solaris render setups can be triggered using our custom FX dependency network. This, for example, here built by Jonas Sorgenfreier, FXTD, doing all the water stuff, sitting there, is the dependency network for a boat wake setup we built here. So including the flip sim, then whitewater, and additional passes like dripping and mist. In between, for every step a QC render, some using Houdini GL previews other Karma renders for shot lighting for final approval. Of course, several FX layers can be pushed from different Houdini scenes, as normally more than one FXTD is working on such a complex shot. Here it was split between the ocean simulation, sail simulation, mist, and the rain atmospherics. The lighting artist gets everything with the load shot node sorted nicely in the FX prim and ready to use. Even though not used on this USD project, a workflow for handling simulated room is also already in place. So what else can we expect in the near future?
Of course, there's a lot of things we still want to add. The first thing would be to finally support the layout node. we already have a prototype. It's just setting up this database file that is where the layout node is based on it. But we just need to implement it so when we push or reject assets that it all updates. But yeah, also with some new features in 19.5, we need and want to support it. Then update log is a big thing where we also already have a prototype running. And it's something that we noticed within our first USD project. So it's now a push pipeline. Artists are working on a scene and other artists push new elements, assets, or shots into their lighting scene, for example. If they would reload their load shot node, they would get it, but they're not really notified within Houdini about this happening. So the update log will run in a separate process, so it doesn't block Houdini, and it's a Python panel. And when something is pushed from somewhere else and it is relevant for an artist's scene, it will just be stacked in this log, and then they can then choose to update their scene. Or if they, for example, work on an FX layer and they have merged animation into SOPs, they could say, no, for now I want to keep this, and I would pin it right there. Then yeah, the fur procedural. We just released our grooming workflow where HDAs get packaged and everything works. But of course, with 19.5, we want to switch to the fur procedural. It's amazing to finally have this. And then yeah, we mentioned it before, we want to support the full crowd systems, and there also use the skeleton exports from Maya because it would result in much smaller caches. And yeah, we would now like to finish by also mentioning some of the open source software that we use, because in setting up a USD pipeline, that's really something to look out for, what is there. Yeah, our publish UI that we've seen, it is based on Piblish. It's a plugin-based system to easily validate and extract elements from a work file. And we have customized it quite a bit. For example, we have a totally custom UI, and we also connected it to FlowPipe. And FlowPipe is used in many, many areas of our pipeline. It's a lightweight framework to do flow-based programming in Python. And in the USD pipeline, we use it to send our publishes via Piblish to the farm in a very optimized way, and it then makes sure that the individual Piblish plugins are able to still share data. And FlowPipe, by the way, is being developed by our head of pipeline, Paul Schweitzer, so I definitely recommend you to check it out on GitHub. FNSE is our render farm manager, for which we also run a custom UI. And as I've shown in the render slides, we also added this additional FNSE settings USD primitive type to be able to connect it to Solaris. And then we use USD Manager that was open sourced by DreamWorks Animation. It is a USD browser and editor, and it's super handy. We've connected to all our, as the default application for all our USD files on disk. So if we double click a USD file, we see it in USD Manager. And finally, the Rodeo Replace Resolver, our initial asset resolver was based on it, and it does the substring replacement. Maybe now with Asset Resolver 2.0 becoming the standard, it might be a bit outdated, but it's definitely a great resource to get started. And then, yeah, finally, here's the wonderful group of people that worked on our USD pipeline over the course of the last 3 years. So, yeah, big thanks to everyone involved.
Yeah, was it? Yeah, I mean, just to sum it up, I mean, we gathered a lot of valuable feedback while working basically on the last voyage of Demeter, and I would say that everybody agrees that that is a very new way of working with USD, but it's also much more efficient, and that makes it also more fun for the artists actually, not waiting forever that something gets loaded. But yeah, as it's this new way of working, it's also important, I think, to get the artists into it, that they understand the concepts. So I think to get them up and running with USD as fast as possible, we have now already more training resources internally available than ever before for the whole legacy pipeline. But yeah, so I'm really looking forward to the next project as well with Solaris, USD and Karma. And before I forget, if you are also interested in maybe working at Rive's newest Houdini USD pipeline, we are always looking for new talent. So get in touch on website or with us here. More people are here from our side. So yeah, thank you. Any questions?
How do you guys lock artists to specific shots? So say you have a sequence 100 shots, right? And you want to lock specific shots to specific shots. The second question, you guys are using the shot switch rather than branching out. Maybe it was a little confusing for me. There was some sections you were actually branching out, but most of the time you guys using the shot switch. So let's say I want to compare shot to shot just to see consistency, right? So
Yeah, I mean, to compare the consistency, you could, you would then, yeah, we're not branching out and putting them next to each other. I think this would probably also be something for, also for future Solaris versions where this would be supported somehow better. But what we would do, we would just, because it's so, the render submission is so integrated into the whole thing that we could just send super quick clay renders to the farm, for example, to block out these things. It's yeah, to check these things, it's often faster to just submit it to the farm, and then to see them for each what it is. We then just use the shot switch and then change the context option and then look at it. So yeah, it's not. It seems to be more the more Solaris way to do, to just switch to that context and then look at it for that shot.
Branching out and combining together, then based on context, we can just iterate what needs to be rendered. And again, about the locking, like how do you guys lock specific shots to the artist? It's like a grouping of the shots goes from the shotgun.
You mean the assignment basically, or for the artist to the shots, or
yeah. Like let's say. Like the sequence has 100 shots, right? And you have like 5 artists to work on.
Yeah.
So how do you guys determine, when they open HIP file, how do they know, like, I'm working only on those shots?
I mean, that's basically all handled in the RISE base, our custom database. There you basically, the artist gets assigned to the shot, and then they will just see their shots to able to open them.
Using different work files, right? Even in the principal shot, they have, like, each artist has their own work file. So that they
that's what we support. I mean, we support lighting scenes. You could have 5 lighting scenes separate for the artist in the same principal shot, and then using those information from the database, they would only work on their shots because it can get pre-filtered.
Okay, and the last question, because we have exactly the same problems. So how do you guys determine the HIP file's name? Let's say it's John and Smith, like you putting like the name of the artist, or it's like a link to the database?
It is the artist name in there because there's no connection for us. We only have a connection to the database to the work file, but the versioning of the work files is not linked to USD. That was an issue we did pretty early on, and it made everything so much simpler. There's the versioning, the naming even of the work file is not what defines the USD layer, but what is set on the export node.
Okay. And if the artist is sick and it should be go to the other artist, how do you gonna like differentiate?
They open the work file of the latest work file of the other artist, and then they version up, and then the export again is not linked to the artist at all via the layer name. So
okay, thank you. I mean, I have way more questions, but
we will later.
We'll be around. Yeah.
What was the workflow like for preliminary lighting to be used by upstream departments to make their renders for publishers and renders? Like base lighting, basically.
Yeah, we have what we do now. We have a custom asset type as well that is environment, and that can then contain many sets, and that can also contain the lighting. So we could set up the environment with its own lighting layer. That is exactly this. And then this could be a variant. So we could have an environment, and we set up variants for day and night. And then we have already 2 versions for this initial lighting. And then in the lighting layers, in the principal lighting scene, they just edit these lights or
Thank you.
modify them.
So are you basically now only using the principal files or also the individual ones, and how do they kind of work together?
The load short node handles this. So we try to use this principal files as much as possible because it's so much easier to have access to all of them. But if you create a work file, even if you create a lighting work file in one of the shots, then if the name, this is where we actually look at, it is not required, but this is where we would look at the work file. And if the naming and the layer matches, then the export node would automatically be filled out with that data. So the layer muting already is working on the lighting layer, for example. So it could then do the next export for this specific layer. But of course, this is something where coordination and the database comes into play, because if we decide that it's not done in the principal shot, then we need to make sure that it's maybe then not connected. Well, because the principal connection is not just a single connection, it exists per department really. We can do an FX connection, a light connection, and everything. So we would then remove the light collection, and then it would not be listed for the principal artist. Or, I mean, it's very flexible. We could do both as well, but yeah.
Thank you.
Okay.
What was the interaction between FX and layout was like when it came to shots that were FX heavy, for example, the stormy sea, and how did layout mock up the shots without the final FX, for example?
I mean, that there also the new USD concept helped because it was this interchange between those departments. Basically they could push something and it would directly appear in for the FX artists, and also the other way around. Basically, it's not just going up in the hierarchy. They can also prepare something for layout that they have this available. For example, as we said, we blocked out quite also some stuff in Houdini actually, and then pushed it again, and that could be loaded in Maya so that they could use it as a base for this kind of stuff.
And in this regard, there's this USD structure, the folder the primitive structure. We have this default prims, and there's this layout prim. And what we could also do is we don't have to define every prim as something that ends up in the final layer. So if we put it in a layout prim, and then it is only used as an intermediate export. So they can reference it, and then the final layer export that should be rendered would be at that final location where it should be. So it's also really usable in this regard.
Did you guys find you need to change the infrastructure? Because again, you have like 1.5 million objects, and it's a huge callbacks, right? Like, so where are you guys baking layers, or are you just like keeping the whole history from the initial asset bundle?
It's the number of prims is there because it also lists the instanceable references, all the individual ones in there. Okay. It was that trick again, but it's still where a lot of assets still. And and regarding optimizations, that's also why we want to at the layout node now, because what we've seen with our multiprops, they were all instanceable references, but there's still a little bit of overhead, because what is still faster would be to use point instances. Mm-hmm. And then just, we have a workflow for that already, but it's not currently being used yet, but you would then be able to extract individual point instances and promote them to references or instanceable references. So if we would then have scattered all the crates there, this whole thing as point instances, it would be much more efficient. So that's one thing that we also, regarding that list, want to add in the future, to rely more on point instancing to increase performance.
I see. But keeping all the layers in a stack, there is no issue, right? Like literally from asset, layout, animation, effects, blah, blah, blah.
Yes, we keep them all there.
Okay.
Yeah.
Okay, good.
Yeah. And it's not just, also it's not just one layout layer, or of course not one animation, it could be several. Yeah.
I just wanted to know, how do you handle invalidation? So when one department does something that affects downstream in a way that certain prims are no longer, you basically have to redo them in downstream departments.
We have in our database, which I didn't show today, we have the option to reject or totally remove a layer from an asset. So they could then reject, for example, an animation layer that was just pushed with a message that they can add to this, and this would then remove it from the shot. It still requires some communication, but this is how we can go back and forth and communicate or even edit invalidation of layers that are already there in the shot USD, if that somehow...
I mean, what's also possible is basically that we can have like intermediate pushes, so it's not like it's getting directly pushed into lighting, for example. It's just like for next department. So that they can push it, like for example, if the model got changed, but shading is not updated yet, it would be bad that it ends up in the shot. So it can be just pushed for the next department, shading can adjust everything, and then they can do the full push to the shot.
Yes, for asset, for example, we have this load asset layers node. I didn't show here, and it would load not just the pushed layers, but you can then basically structure or set up your new package version. You can then select the individual layers and say they all work together because the UVs match to the surfacing and to the textures, and then they can push it as the new version. Yeah,
Thank you.
like this. Yeah.
So guys, unfortunately that's time for now, but I'm sure you guys will be
Yeah,
around
we'll
if
be
you want to
around.
ask some questions. Thank you.